Bismillahirrahmanirrahim. I'm Khadr Chuktai and you are watching my YouTube channel Khadr Chuktai School of Advanced Chemistry. Today I'm going to explain once again the typical questions from paper 2 O-level chemistry 5070 code. And if you are new to my channel, please subscribe, share, like and hit the bell icon for the incoming notifications. At the moment I'm going to explain stoichiometry and mole ratio questions. These are from the past paper history, almost from 2017 to 2021 May, June. Let's talk about it. First of all, as far as my opinion is concerned, before going to solve stoichiometry and mole ratio questions, you must know about the few formulas. For example, the percentage yield, mole, how to find what are the basic steps of the empirical formula, concentrations, and there is a normal method that is basically a mathematical procedure to calculate or to manipulate something that is said to be the unitary method. First of all, the mass percentage or the percentage by mass, you can say. Percentage may be with respect to the mass, percentage may be with respect to mole, and so on. The simplest mass percentage is the mass of an element divided by the total mass into 100. That is said to be the percentage. That is the simplest version of the percentage. Same is the case, percentage can be taken, can be obtained with respect to moles, with respect to volume, and so on. The second one, percentage, is not the normal percentage. It is said to be the specific percentage, or it is percentage yield, and sometimes it is also said to be percentage purity. Here is the formula to calculate the percentage yield. That is, percentage yield is equal to obtained value divided by calculated value into 100. Obtained value is basically the value that is said to be the experimental value. It is experimental one, and it's a calculated value. It's calculated with the help of unitary method or calculation that is said to be the ratio, proportion, and so on. So percentage yield, whenever you are going to encounter with a question of percentage yield or percentage purity, you will have to use this one formula. Just keep in your mind. The next one is mole. Mole can be related and to the various aspect, you can say. Mole may be equal to mass, with respect to the mass, or if the mass is given, MR is given, you can find, you can obtain the answer of mole. So mole is equal to mass over MR. Same is the case. 1 mole is equal to 6.02 into 10 raised to the power 23. That is equal to the number of particles. Whenever you are going to find the number of atoms, number of ions, number of molecules, at that time it will be necessary to use this formula, and so on. The third one, and once again the typical one, is you can change volume into mole of the gas, or the mole of the gas can be converted into the volume at RTP. This RTP is room temperature and pressure. Room temperature and pressure. 1 mole of a gas is equal to 24 dm cube at room temperature. If the room temperature is over here, if the gas is kept on the room temperature, then its volume will be 24 dm cube. The next one is the step to calculate the empirical formula. Here are almost the 4 steps, you can say. Number 1, first of all, if you are having the percentage data, then divide percentage by the molar atomic mass, or that is said to be the AR or MR. Sometime, we call them collectively MR. Actually, in this case, you will divide by AR, not MR. The second one is, you will find the simplest ratio by division. Then you will make the simplest ratio of these both are 3 and 4 options. Finally, if you are having the value of MR, you would be able to calculate the its molecular formula. So once again, if you are having the percentage data, let's suppose percentage of the carbon is here, hydrogen is here, and you are having the percentage of oxygen, then by dividing it by MR of carbon, hydrogen, and oxygen, you will get the simplest ratio between them, and that ratio is in fact indeed the empirical formula ratio, and that formula is said to be the empirical formula, and so on. Here is another formula that is concentration into volume over number of mole, M1 into V1 over N1 is equal to M2 V2 over N2. It's a specific formula that is used for the titration reactions. If an acid is going to react with a base or with an alkali, so you can use this formula to find the missing concentration, to find the missing volume, and number of moles must be given. I mean, N1 and N2 are taken from the balanced chemical equation. The next one is the concentration. Once again, the most oftenly asked question is from the concentration. Concentration may be of two types. It may be mole per dm cube concentration, it may be gram per dm cube concentration, and so on. Mole per dm cube concentration is having formula number of mole into 1000 over V. If the V is in centimeter cube, then you will put 1000 over here. If you are going to deal with the volume that is in dm cube, then you will simply put 1 over here. 1 over V, if the V is in dm cube, if volume is in centimeter cube, then you will write 1000 over V, that V will be in centimeter cube. The second one is, I'm going to expand this number of mole, N, that is equal to mass over Mr into 1000 over V, I mean that is volume in centimeter cube. And the last one, you can also convert, you can also find the concentration in grams per dm cube. In grams per dm cube, you must have the answer from mole per dm cube. So the answer of mole per dm cube can be changed into gram per dm cube by multiplying simply with Mr. If you are going to multiply the Mr, it's a molar mass, the answer of mole per dm cube will be changed into gram per dm cube. And on this page, the last one is unitary method. It's basically the other name of ratio proportion method. It is used in specific scenarios. For example, it is used when equation is given, when formula is given, when you are going to obtain information from formula, from equation, or from given data. Any sort of given data can be maneuvered, can be used with the help of unitary method. What is the unitary method? I'm going to explain on the next pages. Here are a few tips and tricks you can say. If the different compounds are there, but they are having same ingredients, same elements, carbon, hydrogen, oxygen, and so on, and if they are having the same percentage of atoms by mass, if the two compounds are having the same percentage of carbons by mass, same percentage of hydrogen by mass, let's suppose, then its empirical formula will also be the same. The next one is, whenever you are having a given data, then try to develop a chemical equation, a balanced chemical equation to solve that question. If you are having a normal data, a comparative data, you can say to solve a stoichiometric ratio, and if there is no evidence of the chemical equation, then the first try to develop the chemical equation. It will, the easiest way to solve this question. Apply unitary method. That is the typical method, as I told you. Whenever you are going to find, or you are going to deal with the formula, with the chemical equation, with the mass, with the mole. If you are going to find the mole, you may use unitary method. If you are going to find mass, find formula, and if you are having chemical equation, basically, if the chemical equation is given, if formula is given, then there is the easiest method to use to solve the question is unitary method. The next one is where the mole is necessary. You may find help if you are going to find mole, if you are asked to find volume, mass, number of particles, mole, atoms, molecule, atoms, or ions, and so on. To make formula, to calculate volume, to calculate mass, to calculate number of particles, you will find mole. That is the easiest one as far as my opinion is concerned, and so on. The next one is you will have to find the limiting reactant. You will have to find the limiting reactant if both reactants are in known quantity. I mean, none of the reactant is exposed or is basically said to be the excess one. If the two reactants are given, both quantities are given, both moles are given, both masses are given, and none of reactant is said to be the excess, then you will have to use this rule that is said to be limiting reactant. Then first of all, you will have to find the limiting reactant. The next one is you can apply this approximation, or you can say the Khizr rule. Volume of the gas is supposed equal to the mole of gas. I mean, the ratio of the gas volumes between two or more than two gases, it may be equal to the ratio of the moles of the gases between two or the more than two gases, if they are kept at the same temperature. If two gases are kept at the same temperature, they are having same volume, it will be good that it will be accurate to say that they are having same mole. I mean, same volume of the gases at same temperature. Yes, it is meant that they are having same mole. And reverse is also true. If the mole of the gases are same, if the three gases are present at room temperature, they are in equal mole. So simply it means they are having same volume and so on. So these are the typical, the main tips to solve the different stoichiometric calculation. Let's solve few questions. First of all, here is the question that is from May-June 17 to 1 variant. Aqueous sodium sulfate can be used to prepare barium sulfate. Equation is given, barium 2 positive ion plus SO4 2 negative ion goes to make barium sulfate solid. In an experiment, 20 centimeter cube of 0.550 mole per dm cube of the barium nitrate was added to excess aqueous sulfate. Now, he told us it's an excess. Sodium sulfate, I mean, it's a source of SO4. It is an excess. Calculate the maximum mass of the barium sulfate that could be made. The relative formula mass of the barium sulfate is 233. So, as I told you, if the equation is given, you may apply the unitary method, and on the next page he is asking to find the yield. So after that we will find the yield. First of all, I'm going to apply the unitary method. What is the unitary method? In fact, indeed, I'm going to mark equal over here, and I'm going to write the species those are supposed to find, and givens are over here. In this case, I am supposed to find the maximum mass of barium sulfate in this reaction as a result of this reactant. So, barium sulfate is supposed to, mass of barium sulfate, I mean grams of the barium sulfate are supposed to form. With respect to, you can say, the barium nitrate, and in this case you can see that there is no barium nitrate, that is just, there is just a barium 2 positive ion. So, you can find the information of the barium, this barium from this barium nitrate. Here is the formula of barium nitrate, BaNO3 twice. So this barium nitrate is having 1 mole of barium 2 positive ion plus 2 mole of NO3 1 negative ion. It means that the mole of barium nitrate, if there is 1 mole of barium nitrate, there will be 1 mole of barium 2 positive ion. So first of all, I'm going to find the moles. This information, I mean the volume and the mole per dm cube, will gives us the one and only thing that is said to be mole. So I'm going to find the moles of barium nitrate. 20 into 0.550 divided by 1000. What is the answer? Please let me know in the comment section if you are able to send the comments and so on. Okay. Right, please. $20 multiplied by 0.55 divided by 1000. And the answer is, if I'm not wrong, 0.011 is moles. So overall mole of the barium nitrate is equal to 0.11, right? how many mole of barium ion will be there? The similar one, 0.11 mole of Ba, 2 positive ion will be there. So from